All right, limiting reactants. The limiting reactant is the reactant that limits the amount of product the other reactant can make. So the limiting reactant is really, it prevents you from making any more product. Then you have your excess reactant, which will be the other one. And this is what's not completely used up in a reaction, and this is your leftover. You'll have some of this left over. So if you think about making a sandwich, this is what you need to make a sandwich. Okay, this would be your chemical reaction. All this put together gives you one sandwich. Okay. All right, so if this is what we have, how many sandwiches can we make? Well, we have 6 slices of bread, right? And we know that two slices of bread will make us a sandwich. So if we 6 bread, and for every 1 sandwich, we need 2 slices of bread. 6 divided by 2, we can make 3 sandwiches. Now if you notice, I get that you could probably do this in your head, but when we start using chemicals, still geometry. All right, we have 12 pieces of lunch meat. How many sandwiches can we make? Well, I'm going to abbreviate this, 12 lunch meats, and I know 1 sandwich, I need, what did it say? 3 lunch meats, I think, if I remember. So 12 divided by 3, I can make 4 sandwiches with my meat. All right, then I've got 5 slices of cheese, 5 cheese, and for 1 sandwich, I think it was 1 slice of cheese. 1 slice of cheese. So I can make 5 sandwiches with my cheese. So these, what I just figured out, these are called my theoretical yields. I could theoretically make 5 sandwiches with the amount of cheese I have, or 4 sandwiches with the amount of cheese I have. But what can I actually make? Well, I only have enough bread to make 3 sandwiches, right? So that's all I can make. I can make 3 sandwiches, and I'm going to have leftover meat and leftover cheese. So these would be my excess reactants. And my bread is my limiting reactant. It's preventing me from making any more sandwiches. So my 3 sandwiches, that's called my actual yield. That's what I can actually make. And if you remember from the beginning of school when we did our lab, percent yield is actual minus theoretical over actual. And then this whole thing times 100. All right, so now let's do it with chemical equations. Is our equation balanced, first of all? No. Okay, so now let's use it in chemistry. All right, let's balance this. We need 3 here. Whoops. We need a 3 here, and a 4 here, 9, and 8. Yep, okay. So what we're going to do, if you look at question A, if 25.4 grams of aluminum oxide is reacted with 10.2 grams of iron, determine the limiting reagent. Okay, well, if you look at B, it wants us to determine the number of moles of aluminum produced. And we're going to forget about C right now because I don't think I have enough room to do that. Okay, so I'm going to start with 25.4 grams of aluminum, see how many moles of aluminum I can make, and then I'm going to start with 10.2 grams of iron, see how many moles of aluminum I can make, and then I'm going to compare those 2 answers. So 25.4 grams aluminum oxide. And I'm going to use molar mass to get to moles. So 1.96 grams, 1 mole of aluminum oxide. And from my equation, I know for every 4 moles of aluminum oxide, I can make 8 moles of aluminum. Okay, that gives me sig figs 0.498 moles of aluminum. Okay, now I'm going to see how much I can make with my 10.2 grams of iron. So again, molar mass, 1 mole of iron is 55.85 grams. And for every 9 moles of iron, I make 8 moles of aluminum. Okay, that gives me 0.162 moles of aluminum. All right, so comparing these two now, I can't make this. I can't make that much. I can only make this because my iron is preventing me from making any more. So iron is my limiting reactant. So that's the answer to part A. Part B, determine the number of moles of aluminum produced. Well, I can only make this. So that's part B. And then for C, if I determine the number of grams of iron oxide produced, well, I would do the same thing, except I wouldn't go to aluminum. I go to grams of iron oxide. Determine the number of grams of excess reagent left over in the reaction. Okay, well, I'm gonna start with what I can make. I can make 0.162 moles of aluminum. And I'm going to go to grams of my excess reactant, which is the aluminum oxide. So from my balanced equation, for every 8 moles of aluminum, I have 4 moles aluminum oxide. And then molar mass, because they wanted grams, 1 mole of aluminum oxide is 101.96 grams. Multiply across the top, divide by what's on the bottom. All right, I would have 8.26 grams of aluminum oxide left over. So see, this is important with industry. How much am I going to have? How much will I be left over? Because they're all about making money. So I want to use as much as I can and to have as much product as I can with as less reactants as possible. All right, try these homework problems. We'll check them in class.